Good afternoon and welcome to this talk. I hope you all had a good lunch. So this is a very short talk, it's only 15 minutes, so I'm gonna make it as fast as I can just to not miss any content. So what we're talking about today, it's how we can use tunnels to replace load balancers, especially when talking about Kubernetes. First about me, so I work for a company called Digitalis. I lived in the UK, although I originally from Spain, from northern Spain. I mean, in working for the industry for more years than I can count, unfortunately. And my only and great hobby is my Harley, which is I try to ride as much as I can on weekends. About my company, the company is called Digitalis. We do managed services for multiple customers. We kind of do whatever the customer wants, from managing a database to building a Kubernetes cluster or anything that's required within the organization. I'm a principal DevOps, so I look into automation. Automating is really the main thing I do. And I have a special interest in Kubernetes, so I tend to take a lot of the Kubernetes customers, which is why from where this talk actually arises. So what's the problem we're trying to solve? This is a regular standard network configuration. Just for the sake of this presentation, let's assume that the bullets on the right-hand side, they are web servers. So you have a web server, this globally distributed, and you've got a CDN, load balancers in different regions or countries, and then your servers behind. Keep this in mind because this is important for the presentation. So keep this diagram. So what happens if we want to deploy this network into a Kubernetes cluster that is often on premises and not in the cloud? So the difference between running Kubernetes on premises and the cloud is that often on premises you don't have the same network capabilities. You don't get a load balancer. Often you don't get a public IP. You only go through a NAT. So when it comes to deploying anything that is exposed to the internet, like a web server, it gets more difficult. The other thing with using the cloud is, as you all know, for sure, cloud is expensive. It's you pay for anything. You pay for bandwidth. You pay for services you use. That may work well for a small startup, but as it just scale up, it gets more and more expensive. It just doesn't really. The benefits you get from the cloud sometimes don't correspond to the price you pay for it. So if you decide to go on premises or go into a small cloud provider that doesn't give you load balancers, what can you do? So there are two main solutions for load balancers in Kubernetes. One is use MetaLNB, the other one is Kubernetes kubevip. There is a third solution to use node boards, but I don't recommend that to anyone, so I'm not including that in the presentation. Although, having said that, we know of a customer who uses node IPs, so it's not unheard of. What's the trouble with using any of those two is that they don't always work. They require a specific network setup on your cloud provider. So if you're using VGP, forget about any of the cloud providers, Amazon, Google, it's not gonna work. kubevip is only supported in a few cloud providers. The one I remember off the top of my head to support is Hetzner. Maybe one or two more, but not that many. So we're a bit of a pickle. So what did you do at them? You're going to get here. So you're going to go from your customers, going to get to your web servers, but you don't have a load balancer or a public IP to expose. What can you do? So the answer is look into tunnels. Tunnels will give you all of that without the need to a public IP or a load balancer. Let me explain a bit more about tunnels and what I mean by them. Before I start, it's something I should have made clear in this presentation. I just remember it now. I'm talking basically about tunneling, although With tunnels comes zero trust of them, which is a great advantage to mix them both. I'll differentiate them during the presentation, but just again, keep that in mind. Okay, so what are tunnels? If you think of let me go back a second to this presentation. If you think about the network flow, standard network flow, it goes through your client, to CDN, load balancer, servers in one direction. With tunnels, if you look in the arrows in here, the traffic goes from the servers into the CDN and not in the other direction. It's because the tunnels are initiated by the clients, not by the servers in this case, not by the clients connecting. The advantage is that because the tunnels are initiated from one side and not from the other one, you don't require ingress. You don't require a public IP. As long as your servers can get to the internet, can get to the CDN, your tunnel is established. So that adds a lot more security, because suddenly you don't have to bother about firewalls. You don't have to bother about DDoS attacks. Well, in part, yes. But just your network is far more secure when you're not exposing the services. You only expose that IP address you require. In this case, will be 443 for your web servers. That's all. When you use tunnels, most of the time, you also get zero trust in the middle. What's zero trust? Zero trust is the principle of zero trust is that all the connections going to the servers are not trusted. You only allow anything that's trusted. Again, going back to the simplistic example I'm using, you're only allowing traffic to your web servers. That's all to that port. It's also based on the least privilege access. So you're only granting access to not those things you actually required, but also to the people that can also get to it. Let me give you another example. If I'm setting up a channel for my public web server, I'm opening up 443 to everyone. That's it. Everything works. Let's say that that's not a public server, it's an internet. In that case, I want to open the same port 443, but only for those people that can have access to it in my internet. How can you do that? Using implicit trust. Sorry, using no implicit trust, meaning that you only grant permissions to those and that can access the network. Everything is going to be encrypted, obviously, because it's one of the principles of zero trust. And also you're going to be implementing authentication. So those zero trust providers, most of them, they have really good support for multiple identity providers. For example, you could connect your authentication to Google authentication or to Microsoft Azure or to your internal network. So now you've got an internet. Every time you hit the endpoint, you're going to require authenticating before you can go forward. So authentication is leveraged to the CDN, to the entry point, to the tunnel, not to the applications you're connecting to. Even if you got a really a team that is not very careful in your company, that's not very careful with security, and tries to expose services to the internet without due care, the zero trust principles will block that, and you're still going to need to grant specific permissions to those applications to be able to connect to. Now we understand how zero trust and tunnels work. How do you set it up? There are loads of providers. For my talk, and the one I use the most is Cloudflare, which is the one we tend to use. The advantage of Cloudflare is really simple to set up, and it's all managed by Cloudflare themselves. Also, it's worth pointing out that it tends to be free for most companies. So when we advise one of our customers to go look into Cloudflare, they can do the tunneling for free or just for a very small fee. By the way, I have no involvement with Cloudflare. I just like the company. So all you need from Cloudflare is just a domain registered on Cloudflare. Either you can purchase it on the website or transfer it. The next thing you need is the Cloudflare daemon. they will need to be installed into Kubernetes clusters. That's where your endpoint terminates or initiates, however you want to look into it. Because we're talking about specifically the Kubernetes workloads, just use Helm chart. Just get the Helm chart from Cloudflare, tunnels, put it into the, just install the Helm chart with your Cloudflare tunnel, and that's really all you need. And another advantageous thing is because I tend to automate everything. I don't do anything manually. I like kind of like the Cloudflare offers a Terraform provider. So I can create my tunnels via Terraform. So this example would have creating a tunnel for my website, example.com. That gives me tunnel ID. That tunnel ID is used to launch the Cloudflare daemon, and my tunnel is done and dusted and ready to use. It's pretty simple. You have two ways to deploy the Cloudflare tunnel. You can just do you can connect your applications directly from the tunnel to the services on Kubernetes. There's nothing else required. However, if you have specific needs for routing or filtering or anything like that, in that case, I would recommend using an ingress as well. So instead of going from Cloudflare to service, it will go from Cloudflare, ingress, service. So one extra hop, but I will give you the additional configurations and yeah, actually that's what I meant. So on one side you get the no ingress, and there is a with ingress, and you can see that it's only extra hop. There's no big difference to it. What else can you do? Once you do, just as a bonus, and specifically with Cloudflare, it gives you other uses. You can do your tunnels for more than just web. You can do your tunnels for SSH connections. I connect to my bastions through tunnels, so I don't need to install VPNs or anything like that. You get all the device security, so you can configure I could configure my laptop to set this tunnel can only be used from this laptop based on the serial number. So it gives me additional security level. And because it can use tunnels to skip all the VPN requirements. So if I cut my tunnels via Cloudflare, I don't need a VPN. I can do just that. I'm going to give you a use case. So first question is, does it work? Yes, it does work pretty well. And this is one of the use cases we implemented. It's a company called Luxembourg that provides a monitoring tool for Apache Cassandra, Apache Kafka, where it means that they ingest huge amount of metrics from different nodes. So each Cassandra node, each Cassandra Apache Kafka node, it's a client that will send the metrics over via a tunnel to the services receiving the data. And you can see they picks up a fair amount of data daily, and just makes it work. So there's no ingress in here. There is nothing is exposed to the internet other than by the tunnel. It's fully secure, no need to load balancers, and you can run it anywhere. I could use a cheap European provider rather than using AWS, which is 3 or 4 times more expensive, and get my workloads deployed and running. If you don't want to use Cloudflare, there are loads of different options out there. There's a big combination of commercial and open source. Only tested out of those one that's called Pilgrim, which is actually really good. But because you have to run it yourself, you're losing the extra layer of security that the Cloudflare will provide you. But it's good. It's pretty good. And that's about it. I'm running out of time already. So if you want to get in touch, this is me, my LinkedIn and the company's QR codes. And any questions, happy to answer them. Thank you very much.